Well, maybe we shall we get started then, in which case I think it's a couple of minutes past. So thank you very much, everyone, those of you who are here in the room and those who have joined online for this session, which hopefully will be very interesting. So we're going to have it as we're going to have three relatively short presentations, and then really we want the bulk of this this session to be used as a kind of group discussion, so that people can put forward their own experiences, address some of the kind of questions that we've identified in advance as being germane to the topic we're going to be talking about today, which is how better to integrate research compute, use the supercomputing facilities, and integrate them with data storage and research data management. We are RDARI, Research Data Architectures in Research Institutions. It's a bit of a mouthful, so we prefer to say RDARI. It's not even a very good acronym, really, but it will do the job. So we in RDARI focus mostly on the institutional perspective to these things, about how institutions, whether general universities or more focused research institutions, put services together to build a kind of an ecosystem, an environment in which data can be well managed, and we can support fair data and reproducible science and all of the other things that we come here to RDA to talk about. We have four excellent speakers who you shall hear from in a little bit. We do have a collaborative chat, and it certainly has a link in there to the RDARI survey, which we conducted a few years ago. I know that because I just added it. I know that in the chat, if you rejoin the chat, you lose everything that's already been there. So Keith, do you mind putting the link to the collaborative notes in the chat if you've got it to hand? I can do it if needs be. And we might need to repeat it a few times during the meeting just to make sure that any latecomers or people who end up getting cut off and having to rejoin, which has happened to me once or twice yesterday, they can access those notes. I think that's probably enough of an introduction from me. So I'm going to pass over actually to my co-chair, Keith Russell, who will say a little bit about some of the kind of questions we're looking to address. Can I just ask that all our presenters today just introduce themselves and give a few sentences about who they are? But I should start by doing this myself because I realize I haven't actually introduced myself. So I'm James Wilson. I'm head of research data at University College London. That means I'm kind of in charge of the research data storage and the other tools to help researchers manage their research. I am not the person who's in charge of the research compute facilities. So we have our own institutional supercomputing facilities, high throughput computing, HTCs. At the moment, they're not really linked very well with our storage or our data management mechanisms at all, which is one of our sort of motivations for putting this session on. So I'm hoping that I'm going to learn a few things here from people who've got a little bit further down that journey than we have at the moment in UCL. So on that note, I shall pass over to Keith.
Thanks. Thanks, James. So my name's Keith Russell. I'm Manager Engagements and Expertise at the Australian Research Data Commons. I'm one of the co-chairs of this of RDARI. So probably before I kick off and start talking about this session, indeed that round of introductions would be nice. So first of all, Rory, as a fellow co-chair of this working group, would you like to introduce yourself?
Yes, hi everyone. I'm Rory McNeil, coming in bright and early at 3:30 a.m. here in Edinburgh. Looking forward to the dawn very soon of the longest day of the year on Summer's Day. And I'm with ResearchPace, and we provide a connected electronic lab notebook, which is more of a research data management engine, and are particularly interested in the in this integration, in this interface of compute and data, which is affecting tools and infrastructure as well as institutions.
Okay, thanks, Rory. Okay, and then I'd like to briefly go around our speakers for today. So first of all, Wind, would you like to introduce yourself?
Sure, thank you. I'm Wind Coles. Greetings from New Jersey, and It's only 10:30 in the evening here, so slightly better time slot for us. I am the Director of Research Data and Open Scholarship based in the library, and my division within the library handles digital scholarship, scholarly communications, and research data services, which is the main piece that I'll be sharing today.
Okay, thanks. Kurt, would you like to introduce yourself?
Hi, I'm Kurt Hilligus. I'm the Associate CIO for Research Computing at Princeton University, also in New Jersey with WIND in the United States. And my group runs the computational and data infrastructure for research at the university. We provide a lot of hardware, and we also provide significant support ranging from sysadmins through research software engineers.
Okay, great. Thank you. Next up is a presentation we'll be getting from Kenjiro. So Kenjiro, would you like to introduce yourself?
Okay, thank you, sir. Thank you for having me. So I'm Kenjiro Taro from the University of Tokyo. So I'm really happy to be here. Well, actually, I wish I could be there, so I couldn't make it. But I'm really appreciate that I'm being part of the conversation, and I'm doing Director of Information Technology Center, which I will get into a little bit to this later, but well, so it is doing both of research computing and also some IT services. So maybe I'm in a uniquely positioned to do oversighting both of research computing and IT services. So I'll get
Great. Okay, thank you, Kenjiro. And our last speaker for today will be Melissa. Melissa, would you like to introduce yourself?
Sure. Hi, everyone. Melissa Kragen. I'm at the San Diego Supercomputer Center. I work in the Research Data Services Division. I wear a number of hats there. One of them is to help with the GoFair US office, but I also am one of the leadership team for the Open Storage Network. And I'll be presenting on some of the SDSC services, as well as I'll speak a little bit about some organizations in the US that are fostering professional development and community of practice for research, compute, and data.
Okay, great. Thanks, Melissa. Okay, so back to the main purpose for this event and this session. So we were having a discussion within our diary. It's very much about research institutions and about linking up the data and and creating those data architectures within the research institution. And over the years, we've done various sessions which relate to aspects that come up within a research institution and that are important to a research institution. So one of the aspects that we bumped into recently is that the challenges in having supercompute and having a supercompute center within the research institution or closely linked to the research institution, but also having data management systems and processes within the institution. And those two things often don't appear to be very connected. And this was a pattern we were hearing from several of the institutions. So we thought that actually would be useful to have a bit of a discussion around that and see what was happening internationally in that regard and seeing if there's good practice or good approaches in connecting that up. To break the problem down, we sort of tried to analyze it and see what the main issues were that we could identify there. So first of all, I think there's the question, well, what would be the value? What would be the value? Why would you do this? Why would you actually connect up supercompute ecosystems with institutional research data management systems? Then a next step, what could we actually do in practical terms to better integrate supercomputing facilities with data management? One of the other questions that came up in our mind and we posted here is the metadata that could be employed to actually connect up those data outputs coming out of high performance compute or high throughput computing, and other things that we possibly could consider is what would need to be involved in improving the situation. Who would you need to get involved? What is the role of the different players in this space? And how could you connect them up? And are there any lessons learned from either the presentations, but also from the people in our room or virtual room today? So that's really the main purpose of this session, is to try and find out what's happening in this space, and are there lessons we can learn from each other and build on? Now, I don't know how many of you got a chance to attend the session at the end of yesterday, organized by Timia, and I think Timia is actually in the room, or virtual room anyway. Sadly, I was only able to attend the very start of that session, but it raised some quite similar questions around supercompute and data, and how those two worlds operate relative to each other. So I'd be very interested to see if there's any lessons from that session we can feed into this session too. Okay, so I'll now like to hand back to James as our chair for the day. And James, do you want to take this up? And then we can go through the different speakers to set the scene. Just before I do that, one thing, I will repost the agenda in the chat, especially for the virtual participants, and I'll also repost the link to the collaborative notes, and there we will do some of the discussion in the collaborative notes. Please also, in those collaborative notes, add yourself as a participant with your name and affiliation. That way people have a sense who's in the room and who we're talking to. So that was it for me. James, would you like to take it up?
Thanks, Keith. Yes, so when it comes to the kind of discussion session, which we hope to have, if you're online, do by all means put questions into the chat, but also hopefully we will get a good conversation going by participants who are happy to speak up. We do have a microphone, so if you want to talk to the group, people in the room here, you should be able to do so. And I think it's probably time that we kicked off with our first presentation. So I'd like to welcome Wind Cowles and Kurt Hillegas from Princeton, who are going to be talking about what they're doing there.
Great, thanks so much. It's such a pleasure to be here, even if it's just virtually. I'm really looking forward to the conversation. When this topic came up, the timing couldn't have been more perfect. This is a project that Kurt and I have been working on, for a while, as we'll share soon. So we've already done introductions, so I will move to our first slide. So before we get into how we collaborated on building this project that we call Tiger Data, we first wanted to share sort of what this project looks like, what its vision and mission are at a very high level. So we developed a vision, a mission, and goals. We'll share the highlights of them. Our vision for the service is that our community will be able to effortlessly use the service to maximize sustainable research and administrative data stewardship. So it's both research and administrative data through a secure ecosystem of management services, storage, long-term preservation, and access.
And I won't read the entire mission, but I'll point out some of these important things. So we're planning to provide storage capacity, reliability, functionality, and performance. We want to be sure that there are data management tools and services, and we're creating a whole community of practice around this at the university. And the resulting ecosystem will facilitate research and contribute to the stewardship of knowledge.
Sorry, it's not letting me advance the slide. Just a second. Let's try this. Yay, okay. And so we had several goals, but we wanted to highlight just a few of them. That we are creating, it's a faculty-driven service that from the beginning will acknowledge that we'll want to create an expanding set of solutions over time, resources, tools. You know, we're going to be encouraging good stewardship and effective long-term preservation, and provide flexible and performant access to multiple storage systems. So independently, Kurt and I, so I've been at Princeton about 3 years. And in that time, we had been independently seeing seemingly independent needs arise.
So on the research side, we've seen steadily increasing demand for research storage, like phenomenally growing quickly. We can't keep up with it, spending money every year to grow and grow and grow. So that was the first big pressure that the research computing group was experiencing.
Yeah, and we encountered a lot of these are not quite direct quotes, but they're representative of some of the things that we were hearing. And then, of course, on the other side, on the research data services side, we were seeing growing pressures for us to ensure long-term value and accessibility of the research data, right? So institutions and funders invest so much in terms of generating or otherwise enabling or obtaining research data and extracting meaningful value from it. And so we need to make sure that we have a duty basically to make sure that the data don't just get buried at the end of a project. So we need to ensure the long-term value of it, follow fair principles, and be good stewards of limited resources. So of course, these are not independent needs. And so we were left with the question of how to translate these two different kinds of needs into one institutional service that would effectively scale and have over the anticipated continued growth that we'll see.
This is a map, kind of the landscape of what our storage even still currently looks like. So we have a lot of disparate individual independent storage systems. You can see in the upper left-hand corner of our Office of Information Technology has some storage services, mostly network attached storage. In research computing, we have a lot of parallel storage systems that are provided directly to our clusters. The library has their own storage systems, and some of the academic departments and even faculty and instruments have their own storage associated with them. And then my worst nightmare is this faculty bookshelf at the bottom. Graduate students leave the university and they hand a USB disk to their faculty advisor, and that is the archive of their data, which sits on the faculty bookshelf until all the bits fall off. What we'd like to do is design a storage system that has kind of coherent layers to it. And if you start at the bottom, local data will continue to be kind of that storage will be outside of the scope of what we're actually directly providing. It would be funded separately. We wanted to be able to play in the game, for the data to be indexed and incorporated in the system early on. The center working data is data that's dynamic, active now, maybe shared with collaborators around the world or across the university. It can change day to day. And that's really right now the bulk of our storage. So it's figuring out how to do that in a coherent way to provide it to the research community and the administrative side of the house. And then one of the kind of areas of mutual understanding that we had to come to was what is an archive? And so we've defined archival data here as data that there's been an intentional decision made to make the data permanent and static, and that it's basically either publishing the data or permanently storing a set frozen copy of the data. A very intentional process, so much more of the library definition of archive than if you ask a sysadmin, if you create a tar file, it's an archive. But you can see all of these storage systems are wrapped in what is a green presentation layer. So that's going to be software middleware that provides indexing, metadata creation, storage management, and data management. It's kind of the meat of what we're trying to do, and that's what's going to make this a successful project, so that people can manage their data for the entire life cycle of the data.
So Kurt and I realized early on that the Princeton Research Data Service and research computing were natural partners for what would become Tiger Data. So I'll say a little bit about the Princeton Research Data Service. So it was founded in 2019 as a joint initiative itself between the library, the Office of Information Technology, and our Dean for Research Office to provide services, tools, and infrastructure for research data management, curation, and open data publishing. But as we saw, there were really a lot of different moving parts in our current storage approach, and we needed to ensure that what we would develop would meet everyone's needs, it would be able, and our goals, right? If we wanted to have a service that could be transformative for how people engage with their data. So what you can see here, this is a list of, we have about 30 different contributors from about 12 different groups across campus. This includes not just folks from the library and from Office of Information Technology, but also from research centers and academic departments. Now, I want to call out, we ended up with a lot of meetings, and we probably, we stalled out a little, if I'm honest, until Beth joined the team, and she joined Kurt's team. And she brought a lot of energy to this project, and especially in terms of project management. So this was something with so many moving parts, so much, so many different gears turning. It was really crucial to have someone with this expertise, and that was really what enabled us to really move forward. Right, so we had a lot of meetings. Sorry, I'm losing my notes, but so I want to say a little bit about the meetings. Why so many, and why 30 people? I will say this happened during the we started really working in earnest on this project during the pandemic, which the silver lining in that was that all of our meetings were on Zoom. It made it easier in many ways to include as many people as possible, because we're physically in quite distinct parts of campus. And so coming together virtually made things work better, ironically enough. But we, as Kurt alluded to, we had a lot of vocabulary sharing to do, learning what different terms meant to different people, things like metadata, archive, different kinds of storage. So we did a lot of community building even within the group, so that we knew what we were sharing the vocabulary during the various discussions that we had. So a lot of meetings.
And in addition to the meetings, we did a lot of testing. So we looked at a lot of different vendors to consider their products for what would comprise this presentation layer. And so we ran a number of proof of concepts and really ran things through the paces. And it's finding a product that does exactly what we want is almost impossible, because what we're trying to do is fairly new and forward thinking. Find my notes.
And I know, right? So I want to stress that we also realized really early on that what we were really talking about was not just technical infrastructure, but also people. From the people side, research data management takes time. It needs expertise in practices, especially around creating discoverable, reusable data and code. These are skills that researchers might only have implicit knowledge about, might not have the time to prioritize. And so we needed to both understand the pain points involved in the research lifecycle, as well as be intentional about creating a community of practice around data management, having data managers embedded as a role in all of our different research groups.
From the technical infrastructure side, we're building a large enterprise class system that's beyond anything that we've looked at the university so far. So we need to understand scalable capacity, how to create the reliability and redundancy that we're looking for. And we're going to have varying performance needs. And so we can't have a single monolithic storage system. It has to be a collection of storage systems that provide what everybody needs. It has to be easy to move data around within and into and out of this storage and data management system. And we have to have the capabilities that allow for curation and data management. So for our governance model, what we've looked at is this really has to be faculty driven. So if you look at the orange box at the top, Tiger Data Steering Committee, Wind and I will chair that, but that committee will be at least half faculty members and then some representation from academic IT staff as well as administrative IT staff. We'll also have 2 working groups that'll include some people who are on the steering committees, but mostly the people who've been working so far to make this work. So one will be the operations working group, and that'll really be looking at the technical infrastructure to make sure that we're designing something and operating something that's going to be useful and manageable for the university. And then the metadata working group will work on designing the policies and the data management structure that we're looking at. And you can see on the side, advisory, we're going to include input from as many of those constituencies as we can throughout both the design, implementation, and operation of the service.
All right, and that's it. Thank you so much.
Thank you very much. Nice double act. Okay, so we'll do questions for the presenters. I think after all 3 presenters have done their bit. So up to me now to welcome Kenjiro Taura from Tokyo University.
Right. So can you hear me?
Yep.
Okay. Again, thank James, Keith, Rory for having me in the conversation. So I'm really actually new to this RDA symposium, but I'm excited not only by an opportunity to talk a little bit about my view on this topic, but also by the opportunity to learn the status or the feeling of people from other regions. Especially so because as someone working in Japan, I'm always wondering if people in more advanced regions, US, EU, Korea, elsewhere outside Japan, is feeling the same way as we are. So about the need to bring these two countries together and about kind of the separation between the two, which we'll be discussing in the next hour. Or they have somehow already gotten over it. This is what I'm always wondering. And well, actually, the mere fact that the topic is being discussed internationally here is already fascinating to me. And I really appreciate that I can be a part of the dialogue. So before getting into my 2 cents, so a little bit about myself. So I'm doing a professor in the University of Tokyo, and my educational background and also individual research focuses has been parallel computing, parallel programming and system software programming, language or operating system, that kind of things. So I guess in this RDA audience, I am a little bit on the side of the high performance computing and the system guys, and I have a computer science background. So I've been doing in the last 4 or 5 years, director of the Information Technology Center, or ITC. So Information Technology Center is doing, as I said in the introduction, both of research computing infrastructure and IT services, especially for education. And in the coming years, we anticipate that we are involved in research data management things. But for the research computing infrastructure has traditionally been about supercomputing. So in a way, so this organization, I feel, is a little bit different from the typical US or EU organizations in which the same institution is kind of both doing research computing and more like IT services. Maybe it's fortunate when we talk about bringing these two things together. Of course, the ultimate reason that this is happening is the lack of human resources. But anyway, so this is a quick overview of what the research computing infrastructure in Japan looks like. So we have supercomputers. So for supercomputers, we have flagship systems like K computer or nowadays FUGAC, of course. And also those ITC information technology centers like ourselves have been doing so-called tier 2 systems or mid-range supercomputing systems. So our center is one part of it. About the data management, the National Institute of Informatics has recently launched something called the Research Data Cloud. So this is going to be the main thing when it comes to research data management, sharing, and such. The same National Institute of Informatics, or NII, is doing ID management, ID federation, authentication, and single sign-on, all these. Also a wide area network. So this is a pretty quick overview of what research computing infrastructure looks like in Japan. And so why are we talking about this topic of bringing research computing things and high performance computing things and research data management and things like that? So in my view, the primary reason is that the data management, sharing, processing, needs infrastructure as much as traditional high performance computing folks does. So it's especially true because we have AI, ML, and data science as a tool for everybody. But the other thing is, so for those who are doing data-centric research, ultimately need to publish data, and they need an infrastructure for those publication and sharing. And so they need a place for them to collaborate fluently. So what separate the two camps or two things? So that there are some, so whether it's about the requirement, technical, or perhaps culture. So let me go over my take on these gaps I can see. So first about the requirement gaps. So here I list some of the requirements for data-centric research, and here's some list of requirement for HPC or supercomputing-oriented research. So data-centric research, first of all, needs interactive environment such as Jupyter, GUI, visualization. These are centerpiece of these works. And also, so in terms of the infrastructure, they tend to need continuous availability, not submitting a job that should be terminated within, say, 24 hours or 48 hours. That they need to have their resources are continuously available to them, for example, for things like data portal services. They also need an open internet connectivity for data gathering from outside IoT and access to external services. They also need strong isolation between users to handle sensitive data. Also, so in all, they have high diversity in terms of the requirement. So the system should be highly reconfigurable, perhaps with the root privileges to individual projects or individual users. So this is already necessary for catching up with ever-changing, rapidly changing machine learning frameworks. So in terms of the computing data infrastructure, they are not necessarily profoundly different, but still the requirement from the HPC or supercomputing side is fairly different. So they always talk about very high scalability, so at least more than 10,000 nodes. And for that purposes, they are doing batch scheduling to have a high resource utilization. So they are essentially time sharing resources as opposed to providing continuously available resources to individual projects. So they are also interested in cutting edge processors and networking, so ultra low latency and high bandwidth networks. So they are computing infrastructure ultimately, but the requirement is somewhat different. So here's I shamelessly put my plug on a project that we have recently launched called MDX. So it is a medium-sized cluster with virtualization. So it's in terms of the machine shape, it looks like a supercomputer in the sense that we have a bunch of threads and computing nodes. But what makes it different from ordinary traditional supercomputers is that it supports virtualization. So we introduced the virtualization to meet the diverse requirements of data-centric research. So after talking about requirement gaps, so I just try to identify what are the fundamental technical gaps. So if we sit together and talk about what is the research infrastructure needed for data-centric research. So I guess, so the two items I listed here and two items listed here are sort of conflicting in the sense that the data-centric research tends to need an interactive and continuously available environment, whereas HPC cares much about scalability, even if it is sort of intermittently available to individual users, and also high utilization. But it is largely about the machine operational issues. So with will and some ideas, I think we are hopeful that we can overcome them. The other things, connectivity, isolation, root privileges. So those basically require virtualizations, and this somewhat tends to conflict with their need for their appetite for cutting-edge CPUs and low latency networks. So this is one thing that we found lacking in the as a commercial product when we were designing MDX. And finally, cultural gaps. So I talked about cultural gaps in the last, but I'm not necessarily trying to dismiss this. So this is very important. But as a matter of spirit, I guess we just commit to getting over them. So one thing is that a research field that need data science and data infrastructure are far wider than fields that have long adapted to HPC environment. So in order to seriously support those fields, we need to change our mindset, and we need to change our typical mindset about what a typical folks we are like in those fields. So research computing folks, master for researchers in less experienced fields, or people who have less experiences in HPC environment. And also, interestingly, data science researchers. So their background is kind of computer science, but despite that, they have sort of strong computer science background. They have different expectation on computing environment and computational scientists who is sort of satisfied with monolithic environment supporting MPI and OpenMP and CUDA, as long as they are very fast. But data science researchers expect something more interactive and tend to think about how to make it with low code or no code. So this is one area where we might have some culture clash, so to speak. So yes, that's about it from me. Thank you.
Thank you very much, Kenjiro. Okay, so that just leaves our final speaker, Melissa Kragen from the San Diego Supercomputing Center.
Okay, can you see my presentation?
Yep.
Fantastic. All right. Well, hello, everyone. I'm sorry I couldn't be there in person, and I want to thank Rory and James for and colleagues for putting the session on, Keith. So thank you all. It's great to be here and participate in this. I have way too much content, and I am not the most technical person in the room. And so I'm actually going to just gloss over a couple of these slides, but they'll be available later. I'm going to introduce the services at San Diego Supercomputer Center and the Research Data Services Unit. But then I'm going to spend a few minutes talking about some of the organizations that are in the United States that are really focused on building up capacity in this space, this shared community of practice for research computing and data. I'll speak to some of the points to why I think that's important and how it's really, I think, helping us drive professionalization in this space. Okay. Let's see if there we go. All right. So again, very brief and high level process here. And then we'll spend some time talking about organizations. Oh, there we go. let's go back. Okay, so at San Diego Supercomputer Center, we spend a lot of time working with researchers across all domains, both in academic science, but also out in the public and industry, working on societal issues as well as science to enable data-intensive discovery. We provide a number of services that are really infrastructure related. So we have the data center and we provide storage in a number of ways, different flavors of compute and backup services as well. But we also spend a lot of time engaging with researchers to really understand their projects, to help them organize both their data and then the processes they'll need to be able to utilize the compute services. We help translate that research for production. And then we actually provide access to quite a number of research platforms, including HubZero and science gateways. So those are different ways for projects and researchers to utilize compute services through different kinds of interfaces and backend support. We provide sysadmin and cloud integration services, and then soft services as well. Those kinds of organizational or project management services that help support a project or an organization overall. So we spend a lot of time actually supporting large communities such as the EarthCube Coordination Office, for example. So the compute platforms, I won't spend any time reading this. As I said, I'll make these slides available, but we offer these through a number of business models and also different kinds of compute services to support different kinds of use cases. And this includes everything from containerization to VMware, secure cloud, which is where we're able to support access to personally identifiable information and HIPAA kinds of data. That's our protected health data and other sorts of special or secure data. And then we have just general cloud compute that we offer as well. Our newest machine that's going to be coming online very soon, if not already, I think it's in testing now. Voyager is our new high-performance resource for conducting artificial intelligence research for a wide variety of science and engineering domains. It's an innovative system that it's one of the first of its kind available through National Science Foundation resource portfolio. And the architecture is uniquely optimized for deep learning operations and AI workloads. So at SDSC, we also provide various kinds of storage. And in the Research Data Services unit where I work, we provide all of these and a couple in particular. And again, we offer different business models to suit different needs for different kinds of projects or research groups and external users as well. And the storage services support different scales as well. So we can have elastic storage and on-demand or very specific tied to a specific project, just project-based storage in very traditional kinds of ways. So, and we offer both object store and file-based storage services. In particular, one project in particular that we work on is the Open Storage Network. So the Open Storage Network was funded by the National Science Foundation and with startup funds from Schmidt Futures. We continue to have in-kind funding from a number of organizations, and NSF continues to support the provision of new nodes into the Open Storage Network, which is for active storage, or in the way that Princeton described it is the working data. So active data is actively used or working data for a project or group, and we provide this out. It's a national scale service. It's petabyte scale, so we have allocations in here anywhere from a few terabytes to hundreds of terabytes. The nodes are about a petabyte each, and we'll be adding, this is the set of nodes that are available now, and then we'll be adding over this next year several more nodes as those projects come online that are in the pipe now. OSN is low cost, high quality. It's a sustainable and distributed storage cloud for the research community. We provide simple and flexible access and management methods. We have centralized management and a distributed infrastructure and governance model. And I would say that this is, in terms of data management and support for fair data, the Open Storage Network provides a couple of different ways to support findability of data, both through our API and through a portal that we've layered on top. So now I'm just going to talk very briefly about human infrastructure and organizations and communities of practice. And I think once we get to the discussion, we'll have lots more to say across the panel about this. But as there is growing intersection of research computing and data services, we're seeing in the US anyway, lots of jobs that are beginning to sit across either campus information technology units or research computing, sharing roles with the library directly. And we heard about some of that kind of work happening at Princeton. And they're in addition to sort of cross-pollinating jobs, we're seeing new kinds of jobs pop up across universities to really support that bridging between research computing, IT, and the real data needs that are happening, both because of research data management and new policies in terms of public access to research data, but also to help support evolving needs around cybersecurity. So just a couple of organizations. I won't spend long on these. I've added the URLs at the bottom of the slides for these organizations. The research, so RDAT, this is called Research Data Access and Preservation Association. This organization started several years ago, really brings together people from the library, so data professionals from libraries and other organizations on university campuses and research organizations, as well as educators and students and technologists, really interested in helping to manage around the policies and implementation of services for research data, particularly the data that's governed by federal grants, right? I mean, that's what in part drove the development of this organization. And now it's a standalone organization, and they're doing a tremendous amount of work to support the access to common solutions for problems around research data management. This virtual residency workshop, I just wanted to note this here because this is another example. The Advanced Cyber Infrastructure Research and Education Facilitators Group. So this is an organization, long-standing groups of people in research computing that knew that we had to begin to really facilitate access for researchers on campus to both advanced research computing and HPC and high throughput services, and to help really organize the project and help support the researchers access those computing services. And so both the ACI REF, so again, Advanced Cyber Infrastructure Research and Education Facilitators, so people on campuses who work directly with researchers, and that organization grew, and we now have AC REF professionals on campuses across the US. And the virtual residency really helps to develop the cyber infrastructure workforce. So training people both in high performance computing, advanced research computing, and architectures, as well as now the areas really related to building out and connecting with other kinds of services and requirements, such as ethics around AI, collaborating with data professionals from other units, et cetera. So I'm almost done. I know it says only 11, but I'm almost done with my slides here. CARC is another organization that's got some startup funds from the National Science Foundation. It is a research coordination network, meaning this group spends a lot of time really developing meetings and coordination efforts to help build out capacity across the research computing and data professionals communities across the US. There are several tracks, including systems-facing, people-facing, and data-facing tracks. And emerging centers is the newest one. So where there's new or emerging research computing centers to help get those centers off the ground. And they'll be starting up a couple of new tracks very shortly, including a strategy and policy-facing track. And lastly, I just want to mention EDUCAUSE, which is an organization of institutions. So it's institutional membership. It's a national network of higher education institutions really organized around the use and impacts of information technology in higher ed. So not only research computing, but also educational IT. But most importantly, for this audience, I just want to point out a couple of the things that they do, including their annual conference and a cybersecurity conference, but they also publish the top 10 IT issues in higher ed every year and the Higher Ed Trend Watch, which is an interesting place to keep an eye on new sorts of IT issues that are emergent on campus. They provide a lot of leadership training. And I guess I just want to mention too, one of the most recent topics where they're starting to spend a lot of time is, of course, on AI. So I will be leaving it here. There's a whole set of other organizations here, including research software engineering organizations. I'll make these slides available, as I said, because these are important organizations to have an eye on for emerging best practices for all of these areas of research computing and supporting data practices, both locally and then and globally, as well as we get more collaborations around the world for big data. Okay, thank you very much. I thank my colleagues Christine Kirkpatrick and Bride Balderston for help with these slides and a little bit on our funding, and I'll leave it there. Thank you.
Brilliant. Thanks, Melissa. So 3 different perspectives on the topic, different ways of looking at things, stressing the importance of people and education in that. We have about half an hour now, which we'd like to use for discussion. If you want to navigate to the collaborative notes for this meeting, you will see that we've put 5 questions in there to get things started. You're welcome to explore other topics if you would like to. I'm going to pass back to Keith, who with Rory's help are going to work through some of these questions and see if we can try and edge towards some solutions, maybe just ways forward, and look in a bit more depth at some of the issues that we've been hearing about. Keith, over to you.
Yep, thank you. I was just posting the link to the collaborative notes again.
Good idea, yeah.
There we are. So first of all, thank you for those wonderful presentations. It was really interesting and quite different perspectives and very complementary perspectives, I think, also. So as we were designing this session, there were sort of a number of key questions we thought would be worth investigating and exploring a bit. So what we've done is we've written those questions out in the collaborative notes. So please, for those virtual attendants, but also for those in the room that are also online, feel free to go into that collaborative notes document and just start putting in points you'd like to raise from your own experience. So, and you can skip ahead to questions that are further on, and you can already start writing things there. And if you want to speak to them, just put your name in brackets behind it, and then we can give you a chance to provide a bit more background on that. So there's a range of questions. I probably want to start. The first one we've listed here is what can be done in practical terms to better integrate supercomputing facilities with data management. So I first of all, looking at our speakers, the different experiences they already have in that regard. I'd be interested to hear from Kenjiro. You spoke a bit about the two realms of computing and the high performance computing versus the data intensive science. For both of those realms, what would you see as steps that could be taken to better integrate those compute realms with the actual realm of data management and making the data more available and more reusable? So are there specific aspects there that you think from your experiences would be helpful?
Okay, so this is one of the things we like to see in down the road. But so our commitment is so that like I said in the presentation, computing so virtualized computing infrastructure. So when we talk about the integrating supercomputing facilities with a data management, well, so I think it's easier to say, okay, so we have already a supercomputer, so think about how to integrate these two. But well, so like I said in the presentation, there are some reasons why it is not easy. So the traditional supercomputers are not necessarily good for the need for well, researchers doing data-centric research. So that's why we ended up with virtualized supercomputer. And this is, so in my view, this is a significant change from the tradition of academic research computing facilities. And this is hopefully a big step forward. And integrating this virtualized supercomputers, giving isolated environment to individual researchers with some national-wide research data management facilities, which National Institute of Informatics is doing in Japan. I think that this is way forward in my perspective.
Keith, can I follow that up with another question? So
Yes.
that was really interesting, Kenjiro, and I'm not sure everybody will have caught it, but I think that was quite significant because you didn't really focus it on your talk, but you mentioned the NII Research Data Cloud and the RDM Gakunin platform, which is a national, not an institutional,
right,
research data management platform. I'd like to maybe bring the folks from Princeton in. And so what you described is kind of a Tokyo University, I think, computing combined with a national RDM. At Princeton, it seems like you're working on, within an institutional context, trying to combine the RDM and the compute. So that's quite interesting. So maybe the folks from Princeton would like to comment on that. Kind of, is there a national aspect to what you're doing, or is it primarily just institutional?
Yeah, it's a great question. And I think, I was talking with Kurt about how jealous I am about places that have national infrastructure, because that's, we're a little bit more hodgepodgey in the United States. Yeah, I think we are focused at the institutional level, but the research data services, I was so grateful for Melissa to call out RDAP, as well as the other resources that she mentioned. I'd also mention the Data Curation Network, which we're a part of. These are national level groups that are doing amazing work, providing a community of practice and professionalization for research data management. And that informs a lot of our practice. And so, I think from my perspective, what can be done in practical terms is really identifying wherever you are, where is the expertise, right? And be it at the national level, because you have national infrastructure, be it at the local level, is it in the library? Is it in a combination of the library and research computing, or is it in some other program on campus? Because it tends to sit in different places, but recognizing where that expertise is, and then making sure you're in conversations. Because I don't think there's any reason why anyone has to do this work alone anymore, right? It is by its very nature a collaborative endeavor.
I think one of the keys for the high performance computing area is culture change, right? They're used to having, so we have a 20 petabyte GPFS file system, high performance parallel file system. which each of our clusters has their own parallel file system, but we have this big one that's attached to all of our clusters. Some of our researchers use that big one like Scratch, even though we yearn that they don't do it that way. They use it like Scratch, and others use it as an archive, right? So they're thinking their data is just data, and they're putting it in. More than half the data in that 20 petabytes hasn't been looked at, not touched, has not even been looked at in over 2 years, right? So, but the researchers are used to having that there. And we're going to have to teach them a whole new way, a whole new workflow for doing their work. So sometimes they're going to have to say their job script to run their jobs is going to have to start out, go get my data from Tiger Data and put it in Scratch. And then we're going to, part of the presentation layer is going to be command line commands that can create metadata, that can help with the data movement, that can do all of these data management things, so that the researchers, instead of thinking about data management as an afterthought, the disks that they give their faculty advisor as they leave the university, when they're thinking about designing experiments, they're thinking about what the data management looks like before they've even created a single piece of data.
Can I just ask, do you have any ideas as to how you can sort of lead researchers into do this? Because we have a similar kind of situation at UCL at the moment. We have a large data storage area, and we have our cluster file systems and so forth, and the two are loosely connected. But how can you actually encourage people who are using the HPC facilities to process code to actually start adding that kind of metadata and managing the data in that storage space, so they don't just leave things there for 2 years? I mean, do you have any specific ideas that you're looking to try out?
One is that we're reducing, where that 20 petabytes is going away, right? So over the next 3 years, that is going to go down from 20 petabytes to 0 petabytes. So that their workflows are going to change over that period of time. The other is making sure that, and this is where Wynn's group is hugely important, is making sure that the expertise for doing that is there, that they're supported in making those changes. And finally, as one of our faculty members, our director of our Center for Statistics and Machine Learning, said at a meeting, he said, the place to start with this is the first year graduate students. Don't try to convince the professors to change the way they're doing things. Make it so that those early career graduate students are learning from the get-go. They'll be successful with it, and then they'll be able to convince the more senior people to change their practices.
Yeah, I totally agree, Kurt. And I'll just add to that, one of the things that we're doing with the Tiger Data Service is each new project or space that comes in, where we have the support kind of the upper administration to require that there be a person who wears a hat that is the data manager. Yeah. And it might be a grad student, it might be, a postdoc, it might be the PI themselves, depending on, the structure of things. But that'll be the go-to person that my team will interact with to create a community of practice with. So they'll turn to us, they'll turn to each other. Right? We're hoping to be able to create that so that it normalizes it across different research groups. And crucially, we have that person that we can turn to and say, this is your role. How can we help you, achieve your the best research practices for managing your data?
And so thanks. That's great to hear those different perspectives and different angles. Melissa, from your side, having run all these communities, or seeing these communities out there and working in this space, what would you see as the key changes that could be made in this space?
Yeah, so I want to pick up on a couple of things Wynn is talking about and offer a couple other thoughts. So there are a lot of new storage services emerging, and some of them are being designed, and some of them have not yet thought through some of these data management components. And so they're not quite in the same place of maturity, I would say, as the Princeton team is, and in terms of their service design. And that's where I think there are a lot of opportunities, is that as particularly as advanced research computing, as more faculty and researchers on campuses begin to use advanced research computing and high performance compute services, larger and larger data sets will get produced, and there'll need to be better coordination on campuses, I think, for how to manage the flow of data coming out of these projects. And also to have plans off ramps. So let me use this open storage network as an example. Because we have active data, and those allocations come through either the Exceed resource, which is our national supercomputing resource service, distributed service. Our allocations are up to 5 years, and then we can reallocate. But we also need to be thinking about off ramps, specific off ramps to archival services. Just as the way the Princeton team was talking about, which is fantastic. But we need to do this across many other storage services, whether they're national level or local campus. There have to be both the organizational off-ramps and policies around that. And by off-ramps, I mean decision-making processes and then the actual technical service to move data from one storage service to another. If the data will not be deaccessioned and just deleted. And we also have to train people that we have to delete data. We are definitely going to have to work with researchers. We don't like to throw data away. None of us do. I'm guilty myself. I don't like to throw data away. But we're going to have to delete data because we may have solved a lot of the storage problems, but it's not as cheap as people think, and we haven't solved all the storage problems. And the off ramps and deleting data are a couple of those. And I'd like to add just one more thought, and that's on data management plans. So in the United States, if you receive federal funding for your research, you're required to have a data management or a data sharing plan. Now, I'll address the gap. So we have a lot of people doing research that is not funded by the federal government, and they don't usually have to have a data management plan. So this raises a whole other set of problems, and I'll only make one statement about that in a moment. But with data management plans, if we can be part of, and by we, I mean as our organizations on campus and the research compute and data professionals begin working together, as we're doing now, but much more, and there's more coordination, the opportunity to utilize the data management plan from the proposal stage and help the researchers continue to use that data management plan as a way to help data management stay fresh during the project, to remind them about standards they maybe were going to use, and describing the data and thinking about what needs to happen with the data in year 2 and year 3 and year 4. This will actually really help resource allocations on campus, and to really help the services, the research compute and data services, stay ahead of the curve, if you will. And then the other problem institutions need to deal with, which and we're guilty of this at all the institutions I work with. We're not so great at it yet either, but there's a lot of research data or research happening with data that might not have even been developed for research. And those data sort of fall between the cracks or outside of the parameters for institutional and regulatory management. And we need to figure out some coordinated ways for dealing with all that other data as well. And I'll just leave it there.
So Melissa, I'd just like to comment on your comments about deleting data and deciding how are those decisions made, and certainly among our conversations. And this is just among IT staff, not with the actual researchers who own the data. Those have been the liveliest discussions around what can be deleted, or should any. There's some people who staunchly say nothing should ever be deleted because it's irreplaceable. And so it's been very lively discussion. And the universities in the end can't afford to pay for all of it. So we do have to figure out how to make those decisions.
For me, I would say, so I come from an information science field. I was trained at a library and information science school. And I would say that for the information science field, it is a fundamental research problem that we do not have theoretical frameworks for deciding what to keep and for how long. We have some bits of that framework that we've had to build out because of practicalities, and I think that's good. And it's time for a new paper that kind of brings all that together again. But we're missing some real nice theory driven framing of all of that. Yeah.
I'll just jump into to say, I think it's also complicated by the fact that different research communities have their own, where they're in the absence of something overarching like that, there are lots of professional societies that have been academic societies that have decided their own standards for how long you're supposed to keep things for. And yeah, it gets really complicated.
Could I just jump in here and say thank you to everyone. So we've heard fascinating perspectives from a U.S. institution, from a U.S. institution, but also giving a national perspective, and then from Japan. Maybe just invite some audience participation here, because I can see that we have people from all over the world that are attending from also equally interesting institutions, and for example some in Europe. I'd be curious to see if anyone feels so inclined to give us a perspective on how their institutions and also their jurisdictions are dealing with some of these issues.
Anyone in the room, if you want to give a perspective, put your hand up and we'll come around with the microphone. Anyone online likewise?
Thank you. This is Mark Hannell. Don't know if this is on, but everyone in the room can hear me. Hopefully everyone online can hear me. Just with reference to, we provide infrastructure for a lot of universities, and just about the comment on deleting, as for the 100 universities we work with, no one's deleting anything as far as I know. And a secondary thing is the archival workflows as well. I think archival workflows is something that hasn't been considered writ large. A very small percentage of the organizations we work with, I suppose it's research data management to begin with, and then making sure that you've got archival copies of them. But if we're looking at the, the NIH best data practices and best repository practices, I think a lot of organizations struggle to get to that point as an institutional repository, data repository. And so thinking about deleting files, I think we need to be thinking about saving more to begin with. I don't, of course, the very big data centers is a different story. And as we just heard, that it's very much a case-by-case situation, but that's just what I've seen from the outside looking in.
Hi everyone. I'm Amir Pasha from Uli Supercomputer Center. I can second the opinion for me. Even we are pretty big supercomputer center in Europe, still deleting files, it's something happened at end of the lifetime of the storage application. And same reason, like even we have research data management plan when they submitting application, but in reality it's never happens except the time that they run out of capacity. So they ask for extension and say like, what are you doing with your current capacity? So it goes to the negotiation with them. And as much as we push them to archive their data, this almost always happens in the last 6 months of their project, and with some extension that they get from us afterward to say like, we want to move the data, please don't delete this and wait to give us some time. So it's not really systematic.
Yeah, one of the things we try to do at UCL is to organize our storage around the sort of operating principle of research projects, so that you do get a built-in kind of end date where we basically try and nag people to delete things. And people do delete things. They are asked to make a choice about whether to delete or to archive, to Figshare. But a lot of people don't do either, and it just stays there, and we still get it. So we have these mechanisms, a way of interventions, but it's not perfect. And yeah, I mean, we do need to get researchers to think more about that. Oh, sorry.
Hello, my name is Jeff Shim from Sungkyunkwan University here in Korea. Since the laureate is about the different landscapes, at different institutions, trying out different initiatives. At our university, I believe we purchased a supercomputer 2 years ago. I was involved in one of the committees reviewing the purchase. There was a lot of discussion about the configuration of the supercomputer and how we distribute different resources in terms of consumables. But we had zero discussion about data management capacities and responsibilities. So I believe it's a huge challenge for us to convince our administrator that there's this really important, huge aspect to be considered. But at this point, so to me, that's an opportunity at the same time. So that's what is happening. Yeah. So there is no consideration of data management aspect of these precious resources.
Could I say something to that? Because that resonates. I mean, that was something Kurt and I talked about, how do we make the case for this? And I think that one of the things that we stressed was the long-term value of the research data, that if we're storing it for a long time, what's the point, right? If we can't reuse it, and that research data management contributes to that long-term reusability by the researchers themselves, if not by others. That was something else about archiving I wanted to mention too. I think for some researchers, open research practices like publishing data sets is still pretty new and it can be a little scary. And so one of the things that we talk about too is, well, you can archive it for yourself and you'd still want to have metadata and have it be organized and have these principles associated with it that would allow you to reuse it in the future or a collaborator. But what's the point of saving all of these bits if they're not reusable in 5 years?
Wind always talks about future you. You're doing this for future you.
Hi, so can I ask a question for the other speakers and perhaps audience? Can I go ahead? So, okay.
Go for it.
Oh, okay, can I go ahead?
Yeah.
Oh, okay, so a little bit different topic, and it may not be directly related to the bringing the gap between the supercomputing and research data management. But so I'm relatively familiar with how infrastructure goes. So I think I know what I'm talking about when I talk about the infrastructure, but I have no clue of whatsoever actually when it comes to metadata and data curation things. So we talk about this, but I do not necessarily know what I'm actually talking about. So there are some stories I've overheard that these things are handled by the librarians in US universities and things like that. So maybe you wanna teach me a little bit about how these things go in your institutions. So who are actually doing this and whether it's going well or.
Wind, would you like to pick that up initially, probably?
Sure. So at Princeton and in many of the institutions that I am familiar with, it is the library, often in collaboration with another group on campus like IT or sometimes a VP for research office, who are the most interested in this space. And if there's a research data services, it's often housed in the library or based in the library because there's information science expertise there. And so, and those, especially when it's a collaborative partnership, I think can be really successful. Curation is really about going through making sure that the data has the properties that it needs to have. So it's well described, it's structured in a way, it's using open formats. There's a lot of different, there's a standard model for data curation that's all aimed at ensuring that it will be reusable over time. And so, and if you publish it openly, then there's other principles that are also come into play. So that expertise typically lies in the library, at least in American institutions, but it doesn't have to. But that's where it typically gets centered.
So is it basically that just scientists or researchers just give the data over to the librarians, and the librarians are doing the rest of the creations?
It depends. Yeah, it really does. So in our case, we have our own data repository that we curate data into. So that is the library staff doing it. And I should say a lot of the library folks they might be traditional, like coming through a traditional path through librarianship. But in example at Princeton, a lot of them are former researchers themselves, right, who then also have this expertise. But yeah, in other cases, it might be more self-deposit, or it depends on kind of the bandwidth that the services have to do this.
Thank you.
I just want to pick up on one thing that Wynn said, which isn't in direct answer to your question, but it's really important that you know, Wynn was a professor. She knows how to do research, and that not just that she knows how to do it, but the faculty trust her, just like they trust me because I have a PhD in chemistry. I don't do any chemistry in my job, but the faculty trusts that I understand the research process well enough. And the same thing in the library. It's, you know, Wynn knows a lot about metadata and data curation and data management, but that she gets that trust by having that background as well.
I noticed Stefan had his hand up. Maybe Stefan first and then Melissa.
Yeah, I just wanted to comment on this. So in the LRZ, so that's a supercomputing center in Garching near Munich, and also supposedly in the other two German big supercomputing centers, so in Jülich and in Stuttgart, we are preparing approach that in this approach the users are gonna deposit metadata with the data directly. We're giving it a try, and that's mostly data side metadata, which also brings us to one of the questions like further below. And we will see how that's been going. We have also the libraries, of course, doing it, but not so much for the supercomputing part, in fact. So here we're trying direct approach now. Let's see what it's going to be in some years.
Okay, thanks. That's interesting. Melissa?
Yeah, so I just wanted to pick up on the data curation in the US, and so to give a little bit of a flavor that's happening in the EU, which is a little bit different, and that is that we're seeing an emergence of the use of the job title of data steward rather than data curation. And those data steward jobs are sitting in a couple different places. Sometimes they're in the library or they're a joint role, but also we're seeing these data steward roles very much in the way that Wynn described. So all those things, and sometimes, and really also the way Kurt described that there's a real deep understanding because of research training around the data management, so that the real particulars of the data. And so that some of these data stewards are actually embedded or have a full-time role directly in the faculty or the research department at the university, which is a little bit different than the models that have emerged here in the US.
Yeah, we're currently recruiting at UCL a cadre of data stewards who will work directly with projects to make sure that they've got their pipelines sorted out. So from the planning phase to actually automate as many of the processes to capture that rich metadata and get it into our repository systems at the end of it. But of course, it's one of these things that's going to be a challenge to scale because you can employ experts to do it, but they can't work in every project at once. So we're looking at ways of how we can use sort of research funding to actually cost stewards into funded projects, as we already do with software developers and so forth. But it's yeah, it holds out exciting prospects, I think.
Okay. I'm just looking at the time. We've only got 5 minutes left in this session. This has been a really lively discussion and a really interesting one with a lot of perspectives. So I think probably listening to it, I think there's questions around national services and local services, institutional services. How do you mesh that together? How do you ensure that researchers have the appropriate training to best manage their data and work on that? Oh, Liz, I see you've raised your hand. Have you got a quick one or?
Yeah, and it might be where you're heading towards in terms of a question. I wanted to hear a bit more about successful case studies or examples where people have managed to convince their powers that be to invest in social infrastructures beyond the technical infrastructures. Let me know if that was where you're going. If not, I can leave it on the table for later.
I was actually planning to wrap up, so I wasn't planning to position another question. Do we have time for a quick one there? Any good examples how you've enabled this social infrastructure? Wind?
Yeah, I would say for us, going back to this idea of promoting the long-term value of research data, that it needs expertise. It needs more than just infrastructure. That if we just build bigger buckets and to pour the data into, that doesn't mean that we have reusable data at the end, right? Or discoverable, let alone reusable. And so that was an effective argument for us in saying we need more than just more, bigger, faster. We need human expertise to help make sure that the researchers are using the systems that we're setting up for them.
Yeah, we wrote a significant proposal to the senior administration for this project. Most of that was not about the technical infrastructure. Most of it was about the governance and all of the pieces of support for researchers learning to describe their data, curate their own data, and things like that.
Okay, thanks, Win, Kurt. Melissa, any last thoughts on that social infrastructure?
Yeah, just briefly. So I've had the opportunity to work with what was formerly the Eastern Region Network, which is building out collaborative research compute services across multiple institutions, including with instruments. And this idea of policy and sharing the data, multi-institution collaborations, which we're going to need for all these kinds of resources, these compute resources and instruments and edge computing, all these components coming together. We need definitely the human professionals, but we're also going to need a policy and governance with that. And we have not achieved that in the level or the scope that we're going to have that going forward.
Okay, great. Thank you, Melissa. So look, I think we've heard a whole wide range of perspectives here and I think that social infrastructure side of things really tie it all together to collect that metadata to enable reuse both by the researcher but by others, to think about the decision making around retention and disposal of that data. So I think there's a really lively discussion here. I would like to hand back to James now, because there was still one other thing you wanted to raise in this session. So yeah.
So firstly, thank you, everyone. I got the feeling that this is a conversation that could run for quite a lot longer, but we do need to draw it to a close. So there's one final thing. I've been meaning to talk about this the last few times we've had an Ardari session, and the conversation is always so good that I'm loath to kind of cut it short. So I think for the purposes of this, we are contemplating running another Ardari survey of research institutions and the services that they are offering. And how they offer those services. So we ran such a survey in 2019, I believe it was, and it came up with some interesting responses. The data from that survey is, of course, all freely available online with the DOI, and I put the DOI in the documentation. And we as co-chairs have been wondering if it's worth running another one, a slightly updated one, maybe a slightly simpler one, because we only got about 86 responses last time. We'd have liked to have got more, but I think it was quite a complex survey. I'm not going to talk about it at length now, but if you think that your institution might be interested in learning about what other institutions are doing, comparing a few notes about the services you offer, what you do offer, whether you use third parties to offer those services, how they're linked together, all of these things, take a look at the data from the last one, and either just write to the whole group, the Ardari group, or add it to the collaborative notes document, and just say whether you might be interested in getting involved in perhaps helping us design a new survey, and we can compare and contrast some of the results of the previous one, and maybe do a little bit of benchmarking. And if nothing else, I've used the results of the previous one to find people in other institutions who are doing similar things to the kind of things that we've been doing, just so I can go and talk to them and we can compare notes and learn from each other, which is part of the idea of the Ardari group. So I'll let you do that in your own times. I think all that remains to me to say thank you very much for all our speakers, for everyone who's turned up in the room today, for those of you online, and thank you very much for a very interesting discussion. Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
Okay, lunch here, supper, breakfast, back to bed, wherever you are online. Thank you very much.
Thank you all, and we will share. We'll collect the slides and make them available through the Ardari site. So, thank you all.
Thank you.
Thank you very much.